Assalamu alaikum. Welcome to lecture 22 of data mining. So in the previous lecture, we had completed our discussion on clustering algorithms. Uh, we had discussed a number of clustering algorithms by categorizing them in different ways. We talked about partitional clustering algorithms, and we also talked about hierarchical clustering algorithms. And then we also discussed clustering algorithms that were prototype based, that were density based, and so on. And then finally, we discussed cluster validation or cluster evaluation. So clustering evaluation involves supervised as well as unsupervised clustering evaluation. And the idea there is to determine the quality of the cluster that we have formed using the clustering algorithm. So there are various ways of testing the quality of clusters. So no one technique would work well for all situations. So that's the key takeaway from that discussion. So you will probably have to match your evaluation technique to the clustering algorithm. So for example, if you're using a k-means clustering algorithm, then a cohesion-based uh, unsupervised approach might work well because it is also used as part of the objective function in the k-means clustering algorithm. So evaluating of hierarchical clustering algorithm is much more difficult because you have clusters at different levels. And in general, you can use cohesion and separation or some supervised approach for evaluating hierarchical algorithms. But there are also some additional uh, techniques that are specifically tuned for hierarchical algorithms. We did not discuss that actually, but there are some out there. Uh, if your algorithm is density based, then sometimes the prototype based techniques that are based on just one object and its distance from its center may not work well for density based clustering algorithms. So, so you need to be aware of these pros and cons of various techniques and be cognizant of any evaluation that you use using for a particular algorithm using a particular technique. Usually in practice, we'll be evaluating a clustering algorithm using multiple techniques. So, so after clustering, we are going to start outlier or anomaly detection today. So, so most of the techniques within outlier anomaly detection are similar to those that we have discussed in clustering, but we'll go over them briefly, one by one, so that everyone has an idea of the techniques that are available for anomaly detection. So let's then get started. Are there any questions? Any questions? Okay, so we are going to discuss outlier detection. So what exactly is an outlier? So an outlier, slides. So an outlier is basically a data object, could be a single data object, could be multiple data objects as well. We'll see the distinction shortly, which deviates significantly from the rest of the data. So that this is the intuitive definition of an outlier. So outliers are also known as anomalies. And of course, they're also known by some other name, but those other names are less common. You can also call them exceptions or deviations or uh, significant deviations and exceptions analysis. So, but the more common names are outlier and anomaly. Generally, whenever you have data, that data is generated by a data generating process, some phenomena that is generating the data. The idea of an outlier is that if you have a point or object in a data set that does not look or is not has not been generated by that data generating process, then it's an outlier. So of course, the data generating process is not known in practice for most applications. So that's the challenge. If we already knew the data generating process, we would have been able to identify outliers very easily. So that's the challenge. And then, of course, that makes this problem interesting as well. So outlier analysis has applications in many domains, uh, ranging from the sciences to the social sciences and so on. Uh, so you can think of financial frauds as an outlier. You can think of network intrusions as outlier. You can think of some exceptional performance by a student or an employee as an outlier. All of these can be considered an outliers, and they may have various business uh, or whatever domain that you're working on benefit. So we want to find those outliers because they have some benefit for our uh, company or our uh, endeavor. So one question that is often asked is how is an outlier different from noise? So this is actually it's not very easy to distinguish. So noise in general is random variation in the data, and that random variation may look like an outlier because it might be significantly different from the rest of the data. So so if you are detecting outliers as values or set of values that are significantly different from the rest of the data, you wouldn't be able to distinguish between whether that value or set of value is an outlier in the sense of the definition that we talked about earlier, or it's just noise that is randomly generated. So that is the challenge. If you knew the data generating process, then you would be able to distinguish between the two. So for example, noise, as I said, is random, uh, you can say generation. So random generation could fall within the normal distribution of that data or could be outside that normal distribution of data. So if it is within the normal distribution of data, it is still noise, but you won't be able to distinguish it because it is very similar to the normal data distribution. If it is outside the normal distribution, yes, you might be able to identify it, but you may not know that this is an outlier or it's not noise. So that is uh, the distinction between noise and outliers. For most algorithms, you won't be able to distinguish between the two. Okay, so so there are various types of outliers. So the first type is global or point outliers. So as the name suggests, this is one object. This is an object that deviates from the rest of the data. Okay. So you consider the whole data as one global unit, and you look at each point with respect to that entire whole data. If that data is significantly different from the rest of that whole data, then you call it a global or point outlier. Mm. So, so for example, credit card fraud would usually be a global outlier. But if your credit card is stolen, uh, the person who steals your credit card would probably make lots of purchases. Usually, that behavior would not be seen in normal transactions of the credit card. So that particular transaction or a set of transactions in this case would be significantly different from the rest of the transactions in the data set. So that would be a global uh, outlier. As I said, it's usually a point outlier, but it could be a point, single point, or it could be multiple points. Although there's a separate distinction for that as well later on. So the next type of outlier is contextual outlier. So an object or set of objects is significantly different from its context. So the context could, if you think of data as plotted in some space, the context would be nearby objects, right? So if an object is significantly different from its context, then it's called a contextual outlier. So example, a more common example would be, for example, uh, so temperature, for example. So a temperature of minus, let's say 30 Celsius is anomalous for Lahore, but it is not anomalous for, let's say, a city in, let's say, Canada, for example, Lahore vs, let's say, Calgary. So in Calgary, you typically can see temperatures of minus 30 degrees in the winter. But in Lahore, minus 30 would be an anomaly, an outlier. And most likely it would be noise, because I don't think so you would see a value of minus 30 in Lahore, which is actually generated for the data generating process. Okay, so these are contextual. So the outlier is defined with respect to some context, and that context has to be specified. Okay. Uh, so usually you will have some attributes that are context attributes, and then you have some attributes that are behavior attributes. So in the case of temperature, temperature would be a behavior attribute, location would be a context attribute. So you're looking at the values of temperature, but then you're comparing with respect to the context, which is location. So a temperature of, let's say, minus 30 is not anomalous for the context Calgary, but it is for Lahore. Uh, and then finally, we have collective outliers. So these are outliers that are found by multiple objects. So this is a separate category, although in the previous two category, you might have also sets of objects that are outliers. But in this case, so set of objects that collectively form an outlier or anomalous behavior. Individually, they may not be outliers. So that's why we have this as a separate category. Individually, they may not be outliers, but when you put them together, they become an outlier. और इसमें जो सबसे कॉमन एग्जांपल दी जाती है वो इन कंप्यूटर नेटवर्क्स, फॉर एग्जांपल यू हैव द DOS अटैक, डिनायल ऑफ सर्विस अटैक. So what is the denial of service attack? You have so in, so a computer basically tries to access a web page, for example. So that is a uh, uh, legitimate access. But if hundreds and thousands of computers simultaneously access that page or that website, so then that becomes an outlier. And each individual object or transaction or access in that set itself is not anomalous, but when you combine them together, they become anomalous or an outlier. Okay. So these are some types of outliers, and of course, they could be overlap in these definitions. So we said we have global outliers, which are points or sometimes also set of points that are significantly different from the rest of the data, the whole data. And then we have collective outliers, which are again an object or set of objects that are different from the objects in the same context. And that context could be neighborhood, that context could be location, time, whatever. But context has to be defined, and usually we have context attributes that define the context. And then finally, we have a separate category which we call collective outliers. These are a bunch of observations, objects, points that together form an outlier or anomalous behavior, but individually they may not be considered to be anomalous. And the example I said here is like the denial of service attack in computer networks. All right, so what are the main categories of approaches for detecting outliers? So these categories, of course, these categories, again, there are many such categories, but primarily from a machine learning perspective, there are just two. You can have unsupervised approaches, and then you can have supervised approaches. So in unsupervised approaches, uh, we don't have labels for objects or sets of objects that we don't have labels that tell us this object or this set of object is a outlier or not. While in supervised, we do have some labels, and we use those labels to build a model to detect or distinguish between outliers and regular data points, normal data points. So there is another categorization of approaches. So the other categorization approaches is based on the, the approach that is used. So we can have statistical approaches. So statistical sometimes are also known as model based. So usually you will have a model, and based on that model you'll be trying to. I'll talk about this shortly. Let me write out down all the categories in this categorization. So we have statistical based, and then we have proximity based. So proximity is distance, similarity, dissimilarity, and it also includes the notion of density. And then we have cluster based. So these techniques usually use a clustering algorithm. So these are cluster based, and And then we have another type which is becoming very popular nowadays is reconstruction based. This actually uses a, uh, although there are other techniques as well within this type, but most commonly they use an autoencoder, a neural network autoencoder. So let me briefly talk about the first two, statistical and proximity based, and then we'll talk about the reconstruction based as well. By the way, we do have a quiz today as well around 1 p.m., around 3 p.m. Okay. So any questions so far? Okay. So statistical approaches, the main idea here is that we have a model of the data and then we compare our object or set of objects with that model. If the object deviates significantly from that model, and again using some statistical measure, then we say that that object is an outlier. Okay? All right. So usually, let's say you have a data distribution. Let me call this D. And what does this D do? For any, this D would give you a probability for any object X in the data set, right? So this distribution means that you have a probability for every object from this distribution. So you know probability of X. So if the probability of an X of an object is less than some threshold, then this might be a outlier. And of course, you will have to specify the threshold. Then, okay. So that's the general idea for most statistical approaches. So the distribution D could be defined explicitly or implicitly. Uh, and it could be parametrically defined or it could be defined non-parametric. So these are various terms that you will find in the literature. I'm just trying to cover the breadth of it, although in practice, statistical approaches are not used commonly in the industry. Okay. So for example, let's say a very common distribution is the normal distribution. Okay. The bell-shaped distribution. And of course, this distribution could be multivariate as well. If you have multi-valued data set, multi-attribute data set, each attribute is numeric, then you can have a multi-valued Gaussian defining this distribution. So again, we are assuming that the data set is normally distributed. If the data is normally distributed, then for any object X, you can compute uh, its standard deviation, for example. And if that standard deviation is, let's say, more than 2 times the standard deviation of the normal distribution, then or more than 3 times the standard distribution, then you can say that that object is an outlier. Again, you have to specify these thresholds. So if object D is greater than 3 times standard deviation, then it is an outlier. ठीक है? So ये 3 standard deviation होगी या 4 होगी या 2 होगी या 2.5 होगी. This is a parameter that you will have to decide based on your data set uh, and your domain for which you are applying this technique. ठीक है. Of course, you may have some other distribution as well. So other distribution depending on your data set, if it is parametric, तो वो पैरामीटर्स आप एस्टिमेट करेंगे, डिस्ट्रीब्यूशन आपके पास आ जाएगी, उस डिस्ट्रीब्यूशन के हिसाब से फिर आप डिविएशन देखेंगे, उसके सिग्निफिकेंस टेस्ट करेंगे. If it passes the significant test, then you say that it's an outlier, otherwise not. So sometimes distribution parametric nahi hoti, you can use kernel density estimators to estimate the distribution, and then from there you trying to find a deviation. So both techniques are possible. But in general, as I said, statistical techniques are not very popular in practice. So why? Because so model estimation is not easy, or you can say model is not known. So if the model was known, obviously detecting outlier is easy. And to estimate the model, this is not a trivial problem. It's a complex machine learning problem. And then, of course, you have various parameters. Parameters need to be set, which is tricky. Okay? So in general, this works well only for so small data sets. Only larger data sets, it becomes computationally intractable or impractical. Okay. For larger data sets, we typically rely on other techniques. And also works well for uh, data sets with few attributes. So if you have a single attribute, then normal distribution is very easily defined for it. But if you have, let's say, 100 attributes, a uh, multivariate Gaussian distribution is very complex, 100 for 100 variables. And you won't be able to get much out of such a complex model. Okay. One other thing, if your data set is small and even if it's large, but if it has few attributes, you can also use visualization. Detection. So this is more appropriate if you have uh, few attributes. So what can you do? You can maybe have a scatter plot, for example. You can plot box plots, for example. We have studied these plots before as well. You can create box plots, which is plots of uh, the 5-number summary, the median, the Q1, the Q3, and outliers. Okay. So you can have a scatter plot, or you can, even if let's say you have 4-5 attributes, आप dimensionality reduction करके 2D scatter plot बना सकते हैं. और 4-5 से ज़्यादा होंगे तो dimensional reductions के errors बहुत ज़्यादा हो जाएंगे. So it would make sense to project them into 2D and then visualize them in 2D. So as I said, it works well for only a few attributes, maximum 4-5 attributes. Ideally for 2 or 3, but maximum 4 or 5 after dimensionality reduction. So visualization can be done as well for outlier detection. So, and of course, this is semi-automatic, which sometimes may not be appropriate. So human involvement is required. Okay. All right. Uh, so we have looked at the general idea of statistical approaches. You have a model, and then given an object, you decide how far away it is from that model, how it deviates from that model. And depending on the model, you will have various significant tests that you can apply. If your data set is small with few attributes, you can also use visualization. Next, you can let's look at proximity-based techniques. By the way, both of these techniques that we have studied, uh, the statistical approaches, are in general unsupervised. We did not use any labels. Okay, and the next technique also would in general also be unsupervised. So proximity-based approaches are sometimes further subdivided into distance-based and density-based. Okay. Uh, so proximity, as we had studied earlier, could be similarity, could be dissimilarity, some way of characterizing the relatedness of two objects in a data set. Okay. So the simpler approach here is the distance-based, and the technique is simply called the distance-based outlier, or DOB. Distance-based. So the idea is very simple here. Again, this technique would find global outliers. ठीक है, इसमें context पूरा data set है. ठीक है, तो it has two parameters. एक parameter है r, which is a radius. Yeah. Radius. And the other parameter is the Greek letter pi, which is the fraction of objects that lie beyond a given object. So we'll see how this works. So let's say we are considering an object O or some object X. ठीक है? So you want to determine whether X is a distance-based outlier. We have set these parameters of R, and we have set the parameter of pi. So let's say R मेरे पास कोई R radius of the neighborhood, it could be in some units depending on your neighborhood. Let's say radius आप define कर सकते हैं. So let's say 3 मैं दे देता हूँ in general. Or pi basically is, let's say, 50%. So X would be an outlier. X is an outlier according to this if more than 50% of objects in the data set lie beyond R, which is 3 radius of object X. ठीक है? So आपने X लिया, उसका रेडियस डिफाइन किया, उस रेडियस में कुछ ऑब्जेक्ट्स होंगे. अब जो रेडियस के बाहर वाले जो ऑब्जेक्ट्स हैं, if those objects are more than that threshold that you have specified, then it means that this X lies in a low dense region and it's an outlier. So of course this technique would heavily depend on the parameter r and pi. r आप छोटा कर देंगे तो आपका वो ऑब्जेक्ट ज़्यादा ऑब्जेक्ट्स आउटलायर्स बनने शुरू हो जाएंगे, आर बड़ा कर देंगे तो कम ऑब्जेक्ट्स आउटलायर बनेंगे। इसी तरह पाई आप आ, थोड़ा कर देंगे तो कम ऑब्जेक्ट्स बनेंगे आउटलायर्स, सॉरी पाई कम कर देंगे तो ज़्यादा ऑब्जेक्ट्स आउटलायर बनेगा, पाई ज़्यादा कर देंगे तो कम ऑब्जेक्ट्स आउटलायर बनेंगे। तो इफ आई आप विजुअली इसको दिखा दें। तो लेट्स से ये कोई आपका ऑब्जेक्ट है एक्स, इसका कोई रेडियस है, तो इसका आपके पास ये रेडियस आ गया। So, इसके अंदर जितने भी ऑब्जेक्ट्स होंगे दैट्स फाइन। तो बाकी बाहर जो ऑब्जेक्ट्स हैं दीज आर द अदर ऑब्जेक्ट्स, ठीक है। सो इफ मोर देन 50%, जो भी आपने पाई 50 रखा है, इफ मोर देन 50% ऑफ ऑब्जेक्ट्स लाई आउटसाइड दिस रेडियस, दिस नेबरहुड ऑफ एक्स, देन एक्स वुड बी एन आउटलायर, ठीक है। तो आप 50% के नंबर आप छोटा कर देते हैं, लेट्स से 20 कर देते हैं, तो देन मोर सच ऑब्जेक्ट्स एक्स वुड बिकम आउटलायर्स। इसको बड़ा कर देते हैं, लेट्स से 90% कर देते हैं, then fewer objects will become outliers. So two parameters, as I said, are required, R and pi. Both of them are kind of related, and both of them control how many objects that would be found to be outliers in a given data set. Yes. So the parameter is pi, को वो convert कर रहा है actually उसमें, फिर convert कर दिया होगा। Hmm. Uh, so this technique is simple. It finds global outliers. Um, so, but it is sensitive to parameters. And as I said, these parameters and the technique is global, meaning that you have one parameter for one data set. And we do not look at the context, we only look at the entire data set. Okay? So it is sensitive to parameter, you will have to tweak the parameters to find the uh, best set of outliers for your data set. So a related technique, which is actually identical to this in some settings, is uh, uh, to check the kth neighborhood, the kth nearest, the kth nearest neighbor of an object, let's say x. So this k, of course, could be a value that you specify. K could be 1, it could be something else, let's say 2, it could be 3, it could be 5. ठीक है, कोई भी, this is a parameter that you will have to select. So how does this work? So जब भी एक ऑब्जेक्ट लेंगे उसका नेबरहुड देखना पड़ेगा, उसका जो लेट्स से k, लेट्स से मैं कहता हूँ 3 है, and uh, let me take a 1D example. Let's say 1D example ले लेता हूं मैं, 3, 5, 7, 9, ठीक है। तो लेट्स से कि x का 5 मैं देखना चाहता हूँ वेदर 5 इज ए आउटलायर और नॉट। ठीक है। अब इसका और k मैंने 3 रखा हुआ है। तो k द सो एक तो फर्स्ट नेबरहुड इसका 3 है ऑफ कोर्स, सेकंड नेबर 7 है, द थर्ड नेबरहुड इज 9, राइट। ठीक है ना। So the third nearest neighbor is 9, and the third neighbor distance is what? 9 minus 5. So uh, so the third is equal to 9 minus 5, which is 4. ठीक है. So if this value is greater than some threshold, then you call this an outlier. ठीक है. अब ये थ्रेशोल्ड भी आपको स्पेसिफाई करना पड़ेगा. ठीक है. सो व्हाट आर वी डूइंग? एक तो के हमने पैरामीटर सेट करना है. हर ऑब्जेक्ट का जो के नियरेस्ट के उसके नियरेस्ट नेबरहुड हैं वो देखने हैं. जो केथ नेबरहुड है, केथ नियरेस्ट नेबर जो सबसे दूर है उस के में, उसका जो डिस्टेंस बनता है वो केथ नियरेस्ट नेबर डिस्टेंस है. इफ दिस डिस्टेंस इज ग्रेटर देन सम थ्रेशोल्ड, देन दिस वुड बी एन आउटलायर. ठीक है. सो बाय द वे इस टेक्निक में आप यू कैन आल्सो रैंक ऑब्जेक्ट्स बेस्ड ऑन दिस स्कोर, ऑन दिस वैल्यू. जैसे ऊपर मैंने कहा था हर ऑब्जेक्ट का आपका केथ नियरेस्ट नेबर डिस्टेंस आ जाएगा. बेस्ड ऑन दैट यू कैन रैंक द ऑब्जेक्ट्स. जिसका सबसे ज्यादा है दैट इट मोस्ट लाइकली टू बी एन आउटलायर. उसके बाद नेक्स्ट एंड नेक्स्ट एंड नेक्स्ट. सो दिस इज अ गुड वे टू एक्चुअली डिसाइड द थ्रेशोल्ड. तो लेट्स से आपके पास एक uh, एक डेटा सेट था और उसमें ऑब्जेक्ट वन, कुछ ऑब्जेक्ट्स मैंने रैंक कर लिए. लेट्स से ऑब्जेक्ट 20 था, उसका केथ डिस्टेंस आ रहा है 300. लेट्स से एक ऑब्जेक्ट है 50, उसका के डिस्टेंस उसका नेक्स्ट है लेट्स से 50th ऑब्जेक्ट, इसका लेट्स से 250 है. एक्स 100 का लेट्स से 225 है. एक्स 2 का लेट्स से 223 एंड सो ऑन. सो यू कैन रैंक देम एंड नाउ by looking at this maybe let's say next कोई ऑब्जेक्ट आता है रैंकिंग में x let's say 25, इसका डिस्टेंस जो kth नियरेस्ट नेबर डिस्टेंस लेट्स से 20 है. So you can now see that there is a significant difference after 2, 2, 3, and 20. So this might be a good threshold to cut off. And then all the objects above that would be outliers and all the objects below that would be normal. ठीक है. So any questions? There is another technique in this approach, distance based, proximity based, which is density based, which is called local outlier factor. I think I will cover this in the next class. उसमें दो तीन इक्वेशनें हैं, अभी हमारे पास 15 मिनट रह गए. ये हम नेक्स्ट क्लास में डिस्कस कर लेंगे. लोकल आउटलायर फैक्टर. So this, as I said, is proximity based or density based or relative density based. So we will discuss this next time. Uh, so within the proximity based, we had discussed two distance based approaches. One is the simple distance based outlier that requires parameter r and pi. The other is the kth nearest neighbor approach, where you use the kth nearest neighbor distance to rank the objects. ठीक है? And and once you have the ranking, then you can decide a threshold, and by setting a threshold, you will get the outliers. Uh, Briefly, let's go on to cluster-based approaches. So we had studied a number of clustering techniques, and we had discussed that some techniques were able to find outliers during the clustering process. So can anyone remember कौन सी टेक्निक हमने देखी थी जो उसमें हमने explicitly कहा था कि outliers भी detect हो जाते हैं as part of the clustering algorithm? So we use, if you remember, DB scan. So DB scan may we defined objects as core objects, border objects, and outliers. We had, as part of the definition and operation of DB scan, we were identifying outliers. So you can apply, for example, DB scan, it will cluster you the data and it also find you the outliers. So these techniques are cluster-based techniques or approaches for outlier detection. Okay. You can also, of course, DB scan is natural for this, but let's say if you have a k-means algorithm, k-means clustering, although k-means clustering by itself doesn't find outliers easily, it might find, it will always assign objects to its nearest cluster. But once you have the clusters, what you can do is within each cluster, you can apply some other technique like the distance-based technique that we talked about earlier and find out whether there are outliers in that cluster. Okay. So also remember that the k-means algorithm is impacted by outliers in the data set. If you have outliers in data set, the k-means algorithm would not form good clusters. While on the other hand, DB scan would separate out the outliers and then form the clusters uh, without the outliers. So in k-means, basically, you can basically rank distance of object from mean. Okay. And of course, again, you'll have to set a threshold और वो threshold base पे आप फिर decide कर सकते हैं whether this is an outlier or not. Okay. ठीक है. So the other clustering algorithm, I think यही दो थे. Hierarchical clustering में as such कोई additional चीज़ नहीं है. वहाँ भी आप distance based cluster निकाल सकते हैं. तो मेन इसमें एल्गोरिथम बेसिकली जो हमने जो डिस्कस किया वो डीबी स्कैन ही था. डीबी स्कैन कैन automatically find outliers during the clustering process, while in all the other algorithms you will have to add an additional step like ranking based on distance to find outliers. So for example, जो silhouette coefficient था हमने जो निकाला था, तो silhouette coefficient was used for evaluation, but you can also find the silhouette coefficient for each object in the data set. If the silhouette coefficient of an object is uh, for example, 0 or negative or very close to 0, then it might be an outlier. Okay? Remember, silver coefficient close to 1 is considered good clustered object. 0 की तरफ आएंगे तो poor clustering हो जाएगी. Negative में जाएंगे तो clustering खराब हुई हुई है. Silver coefficient. Okay, so we are now moving on to reconstruction based techniques. ठीक है. So actually दो techniques रह गए हैं, LOF और reconstruction based. I am kind of tempted to leave both of these out for to the next lecture because both में थोड़ी सी uh, equations हैं, a bit more involved है. Reconstruction based में, as I said, uh, we will be discussing the autoencoder. So an autoencoder basically encodes an input uh, to some lower dimensions. So it autoencoder basically has two component encoder and decoder. It's trained by training the encoder and decoder together, and then once it has been trained, we just use the encoder. Okay, but for outlier detection, we will have both together, reconstruct the objects, and check whether the reconstructed object deviates significantly from the original value. If it does, then it's likely to be an outlier. तो ये थोड़ी सी इसमें न्यूरल नेटवर्क की फीड फॉरवर्ड ऑपरेशन है, वो फिर नेक्स्ट टाइम हम डिस्कस करेंगे, ये वाला और LOF. तो essentially that's an overview of outlier analysis. इसमें जो मेन एल्गोरिथम्स हैं फॉर इन प्रैक्टिस प्रॉक्सिमिटी बेस्ड हैं, जिसमें डिस्टेंस बेस्ड आउटलायर है, kth नियरेस्ट नेबर है, वो दोनों हमने डिस्कस कर लिए हैं. LOF and reconstruction based we will discuss next time. And statistical techniques are not very common in practice. Clustering based approaches can be used, for example, if you are using DB-scan. Okay, so that's basically the summary. So any questions? ठीक है, फिर मेरे ख्याल से क्वेश्चन नहीं है तो फिर आप फिर क्विज की तैयारी करें, बट क्विज आई थिंक मेरे ख्याल से 3 बजे तक ही शुरू करें फॉर पीपल हु आर बिट लेट. अभी 2-4 मिनट हैं. ठीक है.